Hi, my name is Mohammed Ashraf Yawar, and this is my graduation project, which is about minimum general routing problem. As an overview, we are given an undirected and connected graph G and V prime, which is the subset of vertices in G, and E prime, which is the subset of edges in G. We are required to form a cycle and return back to the starting vertex in such a way that we will visit each vertex in V prime exactly once and each edge in E prime at least once. This is the real life example. Since our algorithm is a generalized version of the Christofides algorithm, let's first briefly go through Christofides algorithm for TSP. Then we can explain the generalized Christofides for GRP. The Christofides algorithm is an algorithm for finding approximation solution to the traveling salesperson problem. And in the worst case, it can be big O of v to the 4, where v is the number of vertices in given graph. It consists of 5 steps in this consider a graph G like this, and in the first step we find the minimum spanning tree using Kroxal's and Prime's algorithm. We can prefer Prime's algorithm since it's slightly better than and faster than the Kroxal's algorithm. In the second step we construct the odd degree vertices in MST, and the third step we find perfect matching, which is the most expensive step of this algorithm, which takes up to a big O of v to the power of 4. In the fourth step, we form a Eulerian circuit when there exists a path that traverses each edge exactly once, such that the path begins and ends. It's called Eulerian circuit. In the first and in the fifth and last step, we form a Hamiltonian circuit, which is a graph in which the path begins and ends on the same vertices. And this is our final result, which is the minimum and optimum route for the given graph in the concept of TSP, or the traveling salesperson problem. And for the generalized version of the Christofides for general routing problem, Klaus Janssen developed this algorithm. Let's go through each step of this algorithm. We are given graph G and V prime and E prime, and we are required to find the minimum circle path. dV is the degree of the vertices in G prime, and VRT is the number of vertices which are exist in V and not exist in V prime. And in this while we check if there's any vertex which is degrees bigger than 2. If there is, then there won't be GRP tour, and we terminate the program. And if there is not, we continue and we find the MST just like the normal Christofides, compute the odd degree vertices, and compute the shortest path for each pair, compute minimum perfect matching, and compute the Eulerian tour using depth first search, and return the minimum circle path. As an example, we can show this graph. The MST is generated. The best solution takes the edges EB and DE, and at the end we will have this circle, this cycle, minimum path cycle. And as an experiment on TSP, we can compare Christofides with exhaustive approach. These are some simulations. This is run with 10 series, 50 series, 200, 500, and these are some graphs which compares iteration count versus tour length. With these two algorithms, one is the exhaustive approach and the other one is Christofides approach. And this is the project workflow, project overall progress, resources, and thank you.